So today in lesson 5, we're going to put it all together. We're going to have all the transformations all together. So left and right, up and down, stretch, compress, and reflect in both horizontal and vertical directions. Okay, so we're going to have all kinds of parts and pieces. So just look at the initial equation here up at the top. Okay, remember A is our amplitude, that hasn't changed, and it's a Y thing, a vertical thing. K helps us get our period. Okay, it's a horizontal thing, it's an X thing. D is our left and right. It's an X thing. We call that our phase shift. And C was our central axis. It's moving up or down. That's our Y thing. Okay. So given our table of values, or given an equation, we can talk about how it's been changed, the parent function or the transform function. Something you definitely want to put in your learning goal sheet, I would say, is this little idea right here. Okay. If I want to take any parent function, I can figure out the transform function by dividing the x's by k. Okay, that's my horizontal stretch to compress. Going left or right, the d value, but remember the left and right, when you come out of this bracket, you have to change your sign. This is why I put a plus or minus there. If it was a minus sign in the bracket, it'd be a plus sign on the arrow. Okay. Underneath, to affect the y's, I'm going to amplitude, I'm going to multiply my y's, and then I'm going to add or subtract according to what it says at the end there, the c, move it up or down. And we'll do a couple of these just to make sure we're understanding this, but that's really what we want to do. And here's our 4 words down here. So A is our vertical stretch, compress, reflect, multiplying the y's. K is our horizontal stretch, compress, reflect. We're dividing our x's. And D is the horizontal translation. We call that the phase shift. And we're going to add or subtract. That moves it left or right. And C is our vertical translation, our central axis. And we're going to add or subtract to the y values. So just in words, exactly what the things on the arrows say. And let's give some a try here. State the transformations for each function, then the amplitude, period, and axis, and we want to find the range for each graph. Okay, so transformations, things that have changed from normal. This first one, the normal graph would just be cos x. So every time I see a number, for example here, here, and here, it's been a transformation. Okay? The thing inside the bracket, that's your k value. That stretches or compresses things horizontally. Okay? It looks like a half, but remember that x's actually do the opposites. So we'd say this is a horizontal stretch by 2. Okay. Inside here, I see the D. D moves the things left or right, but remember again, they do the opposites. So it says add 180, so we're going to go left 180 because we actually need to do the opposite. That would be my phase shift. And the thing outside, that's my C value, that's moving my graph up or down. I do exactly what it says because it's the Y value, and that would be an up 1. Okay, there's our 3 transformations. What is our amplitude for this? Well, our amplitude is that number out front, the first one right here, right? We don't see anything, so our amplitude is still 1. The period, we have that nice equation. Period is 360 divided by k. We just said k was 1/2, so we end up with 720 degrees. And c is our central axis. When I do the equation of the axis, well, I already have that. I just write down y is 1. Okay, and there's my 3 important properties. Now the last part wants us to get the range for each graph. We haven't done range in a while, but you might remember that range should look like y between 2 numbers. How do we get those 2 numbers? If you remember, the minimum is your central axis, your average, minus your amplitude. What was our central axis? It was 1. So 1 minus 1 would give us 0. Okay, and over here, maximum is central axis plus amplitude, or 1, that's our central axis, plus our amplitude of 1 gives us 2. There's our range. Our whole graph is between 0 and 2. Okay, give the second one a try yourself, see if you can figure it out. I'll take you through it if you're not sure. Okay, every time I see a number, that does something. Okay, I'm going to put the letters in underneath. I see 4 things. A, K, D, and C. And what does the A do? That's a vertical. It's a Y thing. It's a vertical stretch by 2. The K thing, it's a horizontal thing. The X's do the opposites, right? So it's a horizontal. It says 3, which means I'm dividing by 1/3. D is the next thing. It does an opposite. It says subtract 40. So we're going to actually add 40, which means we're going to the right. 40. And the thing at the end over here, it's another Y. It says minus 5, so I do what it says. It's going to move my graph down 5. Okay, so you had 4 transformations that time. Our big properties, our amplitude. Amplitude is A, so our amplitude is 2. Okay, vertical stretch, amplitude, go together. The period is 360 divided by K, and we said K up here was 3, right? So it should be a third the size it used to be, which if we divide by 3, it is. And our central axis is Y equals the C value, and in this case it was negative 5. Okay. I want to get the range of this one. So let's start off by writing out Y is going to be between, okay, my central axis, that's negative 5, minus my amplitude, that gives me negative 7. My central axis is negative 5, plus my amplitude, oh, it's negative 3. There's my range. Okay. That takes us through some descriptions. We're now going to try and graph these things a little bit. So on the back side here, okay, we want to make the table of values for these functions. We've got multiple things going on at once. Same old thing we've always started with. Make the basic curve first. X, Y, 90, 180, 270, 360. It's a coast curve, so we're starting at 1, 0, negative 1, 0, 1. Okay, we're going to transform that into a brand new function. I don't need to graph it, just going to make the tables right now. Okay, the 2 is my amplitude, right? That's my 2. It affects my Y's. And the next number I see is this minus 90. 90 is moving it left or right. That affects my x's. It's my x direction. X's do the opposites. So x plus 90. Y's do what they look like. So I'm going to multiply my y. I'm going to stretch it by 2. Okay, my new table would be 90, 180, 270, 360, 450. Add 90 to each of them. Y's times 2, 2, 0, negative 2, 0, 2. And I could graph that if I needed to. Okay, so some keys there. Remember, the things inside the brackets are x's. X's do the opposites. Things outside the brackets are y's, and y's do exactly what they look like. Okay, try the second one yourself, see if you can figure it out. Start off with a sine curve. And we're going to transform that. All right, what are we doing? Things outside the brackets are y things. Things inside the bracket are x things. Y's do what they look like. So I got to do negative 1/2 of my y's, or negative 0.5. That means exactly the same thing. My x's, I have to do the opposite. So I have to divide by 2. We always said we want to divide by k. Here's your k, right? And here's your a. Okay, so take my x's, divide by 2. 0, 45, 90, 135, 180. Negative 1/2 of 0. Well, that's still 0. Negative 0.5 times 1 is negative 0.5. 0 we said was 0. A negative times a negative will make a positive 0.5 here, and then 0 is 0. And there's your new table. We've reflected it and compressed it vertically, and we've also compressed it horizontally. So this would be a really squishy one. And last one. We're actually going to draw this one out this time. Okay, one cycle of this big giant equation. Let's do what we've always done. Start off with your table of values for a coast curve. 0, 90, 180, 270, 360, 1, 0, negative 1, 0, 1. Okay. A, K, D, and C. We said the very first thing to, I think I said put on your learning goal sheet probably, okay, on the top, we're going to take our x's and we're going to divide by k. And that's horizontal compression. And then we're going to move it left or right according to whatever D says. It says plus 60, so I do the opposite. On the bottom, we said multiply your y's by a. So vertical stretch. And then move it up or down according to C. So plus 1, just the way it looks. Okay, we're going to get a new table. And my new table will look like, okay, lots of mental math here. 0 divided by 2 is still 0. Minus 60 would be negative 60. 90 divided by 2 is 45. Minus 60 is negative 15. 180 divided by 2 is 90. Minus 60 is 30. And you notice it's following a pattern. You're just going to put 45 each time, right? So based on that, I know the next one's going to be 75. And then 120. The y's. 2 times 1 plus 1 makes 3. 2 times 0 plus 1 is 1. 2 times negative 1 plus 1 is negative 1. And I've already done these numbers. Then we're going to graph that. So back to doing some estimating. So negative 90 is here. So 60 and 30 would be 1/3 of the way in, right? So negative 30 and 3 about, sorry, negative 60 and 3 about there. Negative 15, halfway between 0 and 30 would be about here, right? 30, okay, that's 1/3 of the way into the next block. 30 and negative 1, about there. 75 is halfway between 60 and 90, so about there. And then 120, 1/3 of the way into the next block, could be about there. So if I were to graph this, I get that equation. Okay, which, if I look at my equation, it's been vertically stretched, so twice as big. It's been moved up one. My central axis is above 0, which makes sense. Okay, it's moved to the left. Definitely, I'm on the left-hand side of the axis. And horizontally, it's been compressed. It's not nearly as long as it used to be. That also makes sense. Okay, and there is our equation. That takes us to the end of that one. Again, try the quiz again tonight. There's some homework questions to give you some practice first. See what you can do.